Hello and welcome to another EE140 video. Today's problem is from our homework number 9, question number 1, and this is about reflection and transmission waves. So let's begin. So first we are given a wave in air with H field given as this function, and that is in milliamps per meter. Now this wave is incident upon a surface of dielectric material with n equals 15, and the wave or the material is occupying the half space z is greater than 0. So we need a full expression for the reflected E field and the transmitted H field. Okay. It's also asking us the reflected power and transmitted power in dB. So what I do to help me out is write down some kind of a roadmap or a flow chart, if you will. So we are given, so this H field is incident, okay? So we are given H of I. So from H of I, we know how to get to E sub I. And from E sub I, we could get into E sub R. So that will take care of this reflected E field. Okay, but how about the transmitted H field? So for transmitted H field, if we arrive at E sub R, we could get from E sub R into E sub T, that's E field transmitted, and from E sub T we could finally arrive at H of T. So from H of I, what do we know? We know that the wave is again coming from air into something else. Okay. So we know that something else has an n equals 1.5, and we know that air just has an n equals 1, and quick reminder, n is equals to root of epsilon r. We know that the material occupies half space, z is greater than 0. So if we let this be our z and let this be our 0, the whole half is going to be n equals 1.5. Okay. And we also know that h is right along the x-axis, so we'll designate this as our x-axis. Transition from air into something else is going this way. So we could also say that k, at least k sub I is also moving from left to right along the z direction. We could figure out our omega, and omega is just going to be omega. So we could use this relationship. C is just speed of light, 10 times or 3 times 10 to the 8th. N is just N for air, which is 1. Okay. We have K, so rearranging the terms, we need to determine our direction. Okay. So to determine the direction of E sub I, we have a K going here from left to right along the z-axis. So we let that be our right thumb. We know that H is initially along the x-axis, so this one H of I is along x. So we'll let H of I be the curl of our fingers. So with that, our E somewhere in this axis, E is our fingers, or uncurled fingers. So if we have our thumb going along the Z axis, the curl of our fingers resting at X, if we uncurl our fingers, it's going to be pointing into the page, right? So E, fingers, into the page. The question is, what is into the page? So let's see, we have X and Z axis. So if we let X be our thumb, right thumb, and we let Z be our right middle finger, and our Y, remember, is just our pointing finger. So if we orient our right thumb along the X-axis and our right middle finger along the Z-axis, doesn't our pointing finger pointing towards you or towards yourself? So that means our positive Y is coming out of the page and negative Y is pointing into the page. So since our E, or E field, E sub I field, is pointing into the page, then therefore E field, or E sub I, has direction negative Y. So now we could write our E sub I. Remember, the format is direction, magnitude, phase, and unit. So E sub I, direction is going to be negative Y hat. Magnitude, okay, so we have to figure out our magnitude. Magnitude can be obtained by this, E naught over H naught. And since we're dealing with incidence, so E naught of I, H naught of I is equals to eta, and eta is equals to eta naught divided by N, eta naught being 377 ohms for non-magnetic materials, and N is just N for air, which is 1. So we could say that E naught of I is equals to H naught of I times, and that comes out as, since H naught of I is just 2, so we could say that E naught of I is just 2 N naught, or eta naught. Okay, so over here we could just write down 2 eta naught, and our phase, we'll just copy the H field phase, sine, put in our omega, 1.2 times 10 to the 9th T. That's going to be minus 4 Z. Our unit is, since we went from milliamps, so this is going to be millivolts per meter. So let's look at our roadmap. So we came from H of I, we just obtained our E sub I. Now we could find out our E sub R, or reflected. To get E sub R, we use this gamma, or our fraction of reflection. You could obtain this using two formulas. It's up to you which you find easier. So it's either use eta 2 minus eta 1 divided by eta 2 plus eta 1. Or you could use n2, or I'm sorry, n1 minus n2 over n1 plus n2. So for me, this is simpler. So I like using this. So this is what we're going to use. So if you use the top one, either way, you'll arrive at the same answer. So n1, or air, is just going to be 1 minus n2 is given as 1.5 over 1 plus 1.5. And that just comes out as negative 0.2. That's for our gamma. And gamma is also equals to this relationship, E naught of R over E naught of I. E naught of R is equals to negative 0.2 times 2 n naught. So that is going to be our magnitude for E reflective. So for E reflective, we need our direction, which we just copy again from here. That's going to be negative y hat times our magnitude. Our magnitude is given by this too, right? So we just negative 0.2 times 2 n, or eta naught. Now our phase is still going to be sine, right? Sine 1.2, that's for omega, times 10 to the 9 t. And reflected have a negative k, or the opposite way. So negative times negative, that's going to be positive for z. And again, this is millivolts per meter. And finally, we let the sign of the magnitude dictate the final direction. So negative times negative is going to be positive z, or positive y hat, right, times, so 0.2 times 2, and we know that n naught is just 377 over 1, which is just 377. So we have 150.8, and that is sine 1.2 times 10 to the 9 t plus 4z. So now we just obtained our e's of r, or the wave function for E reflected. We could cross out this one, so we're done with this. Now we're doing, coming from e's of r, getting the e's of t in order to get to h of t. So we are now doing this. What can we do to obtain e's of t? Remember tau, and that is equals to 1 plus gamma, and seeing that gamma is negative 0.2, that's just going to be 1 minus 0.2, and we get 0.8. Now since we have 0.8 here as our transmission coefficient, tau, let me write it down, tau is also equals to E naught of t over E naught of I. Now, quick reminder, this is only true for normal incident. So we have this number over here. We have E naught of I, so we could solve for E naught of t. E naught of t is just equals to 0.8 times what is our E naught of I? That is just 2 times eta naught. Okay, so we get 603.2. Okay, and that is our E naught of t. If incidence is on this side and transmitted is on this side, they'll have different k's, because remember, k is from this equation, and the k we got for incidence is n1, or it involves n1. Now for the transmitted, it will involve n2, so it's going to be a different k. So we could easily solve for that. Right? So we do omega over k2 this time equals v equals c over n2. And again, this is speed of light, 3 times 10 to the 8. Now n2, what is n2? It's given to us 1.5, right? So that is the n for the second medium. So we could write it down as 1.5, and from there, k2 is just going to be equals to omega times n2 over c. That is 1.2 times 10 to the 9th times 1.5 divided by 3 times 10 to the 8th. That just comes out to be 6. So now we could write down our function for e's of t. That is going to be E transmitted. Now the direction is going to be as the same as e's of I, negative y hat, right? Negative y hat. The magnitude is given over here. Okay, so that's 603.2 times the phase. The phase is still going to be the same, sine 1.2 times 10 to the 9th t negative 6z, and that is millivolts per meter. Let's check our roadmap again. So we got e's of t. Now we need to go to h of t. And to obtain h of t, we draw an axis. Okay. So from here, we know that case of t is traversing along the positive z direction, and e's of t is initially in the negative y direction. So let's copy the axis from before. So from before, negative y is into the page, positive y. Okay. So negative y is into the page, positive y is out of the page. So that means that E t is into the page because negative y. Okay. Remember, K is our thumb, our right thumb. E is just the fingers. H is the curl of the fingers. Curl fingers. So if we have our thumb along the Z direction, and if we have our fingers laying flat along the negative Z or negative Y, which is into the page, if we curl our fingers, isn't it pointing along the positive X direction? So that is our H, which is curl fingers. This is just fingers. So we know that H of t has a direction of positive X, right? So let's write down H of t. The direction is just X hat. Now how about the magnitude? Remember this E naught over H naught is equals to eta, which is eta naught over N. Right? We have E naught, we're looking for H naught. And H naught is just going to be E naught over N, or eta. Okay. And that is going to be H naught equals 603, remember, from here, 377 divided by 1.5, because eta naught is 377 divided by N, which is on this side, it's going to be N2, which is 1.5, 2.4. So our magnitude for our H transmitted is just 2.4. Now, the phase is still going to be the same, sine omega t, and the same k, negative 6z. And that is in milliamps per meter. Alright, so we also took care of this. Alright, now we just need to find out what are the reflected power and transmitted power. So power. Now remember this relationship. So for reflected power, it's PR over PI. Okay, and that is just equals to gamma squared. And recalling our gamma, it's not that one, it's this one, negative 0.2. And negative 0.2 squared, negative 0.2 squared is just going to be 0.04. And what that means is that 4% is reflected. Alright. Now if 4% is reflected, that means that 96% is transmitted. Don't you agree? So we could find out. So P of t divided by P sub I is equals to 1 minus gamma squared equals 1 minus 0.04, and that is just 0.96, which is 96%. But we are asked to state the power of both reflected and transmitted in dB. So how do we do that? So for reflected, we just do the log of that. So 20 log negative 0.2. Right? So that just comes out as negative 13.9 dB. If you're getting an error, just plug in 20 log 0.2. You'll still get the same answer. Now for transmitted, it's going to be 10 log 1 minus r, or gamma squared, that is 10 log 0.96. That comes out as negative 0.177, or just round it off to negative 0.18 dB. The power for transmitted and reflected waves in terms of decibels. There we have it. I hope this is clear. Thank you for watching and have a great day.